Hello and welcome to Isabella's explanation of math things. Today's problem will be from Unit 9, Probability and Statistics. The question reads as follows. The basketball game at CPM Land costs 50 cents to play. In this game, the player shoots 3 times. If the player makes 0 baskets, they win nothing. If they make 1 basket, the prize is a plastic puzzle worth 5 cents. For 2 baskets, the prize is a small stuffed toy worth 60 cents. Making all 3 baskets wins a large stuffed animal worth $2.50. The basket rim at CPM Land is so small that the chance of anyone making a shot is 30%. Letter A reads, find the probability of making 0 baskets, 1 basket, 2 baskets, and 3 baskets. Well, the first thing we need to understand is that there are 3 sort of event layers here. Shot 1, shot 2, and shot 3. Since there are 3 events, the best way to illustrate this would be via a tree diagram like so. The first time we shoot, we either make it or we don't, and the same is true for every subsequent shot. But we know that we only have a 30% chance of actually making it and a 70% chance of missing, so we can label each of these helicopter, oh my gosh, okay. So we can label each of these possibilities with a 0.3 and a 0.7, which are still percentages, by the way, just in a different format, just to make things a little easier to multiply, when you'll see in a moment. We should also look at our possible paths. So let's see. Every time you play, you can miss, win, miss, miss, win, win, and so on. You can make either 0, 1, 2, or 3 baskets, so let's label each possible path with the number of baskets made. Alright, now that we've got everything laid out, we can begin to calculate percentages. The way we do this is to multiply the likelihood of each branch happening. So let's start with miss, win, miss. The numbers here are 0.7, 0.3, and 0.7, which stand for the possibilities of these things happening. When we multiply all these values together, we get 0.147. This may seem like a random number, but if we multiply this by 100 to make it a percentage, we're left with 14.7%. So the likelihood of you missing, winning, and then missing a shot again is 14.7%. Does that make sense? We can perform this process for every single branch in our tree. So miss, win, win. The values here are 0.7, 0.3, and 0.3, which come out to 0.063, and if we multiply that by 100 to get our percentage, we're left with 6.3%. So again, the possibility of getting this particular branch is 6.3%. So now you do what we just did to every single branch, multiplying out the decimals for each choice and then making it a percentage. You can pause the video now and do that yourself. Alright, if you did everything correctly, you should end up with 14.7%, well, 14.7, 6.3, 34.3, 14.7, 14.7, 6.3, 6.3, and 2.7. Notice how the same percentages correspond with how many baskets we made? Alone, these percentages don't really mean anything, but if you add the similar percentages together, you're left with a percentage of making that number of baskets. If you add these 3 values of 6.3 together, which all represent branches that make 2 baskets, you get 18.9%, which is the chance of making 2 baskets overall. This is the way you answer letter A. You have a 34.3% chance of getting 0 baskets, because that's the only value for 0 baskets. If you have a 44.1% chance of making 1 basket, because that's all the values for 1 basket, 14.7 added together. You have an 18.9% chance of making 2 baskets, like I demonstrated before. And finally, you have a 2.7% chance of making 3 baskets, because that's the only value for 3 baskets. If you add all of these together, they come out to be 100%, which is pretty much a green light, saying that all our values are correct. Alright. Moving on to letter B. Darnell really wants to win a prize to bring back for a little kid who lives in his neighborhood. Which prize is he most likely to win and why? Well, let's look at our previous answer. The highest percentage for anything was making 1 basket, right? 44.1%. According to the problem, we win the plastic puzzle if we make 1 basket, so Darnell would most likely win the puzzle because the highest percentage of anything happening is that he makes 1 basket. Finally, letter C. How much money should a player expect to win or lose in the game on average? Is CPM Land making money? This one is a little tricky, so let's again go back to our answer for letter A and add the amount of money you win or lose at each time. Remember that it costs 50 cents to play. If you make 0 baskets, you lose 50 cents. If you make 1 basket, you lose 45 cents, since the prize for 1 basket is only worth 5 cents. If you make 2 baskets, you win 10 cents, since the prize is worth 60 cents. If you make 3 baskets, you win $2. So how do we answer letter C? Well, you can actually multiply these together. 0 baskets becomes negative 17.15, 1 basket becomes negative 19.85, 2 baskets becomes 1.89, and 3 baskets becomes 5.40. Can you guess what these numbers mean? They mean that if you played 100 times, you would lose $17.50, lose $19.85, win $1.89, and win $5.40, which is pretty bad. We can add all of these together to get a total amount of money won or lost. Combined, you get a huge loss of $29.71. So, if you played 100 times, spent $50, you would lose $29.71. But the question asks how much money you lose on average or every time you play. It's pretty simple to get that answer. Just divide these negative $29 by 100. So if you played 100 times and you lost $29.71, then each time you lost about 30 cents. So every time you play, you lose 30 cents, and CPM Land makes about 30 cents. So yes, the answer is that they're making money. And cents, because it's cents. Now, you might think, well, why is this important? When you gamble, if you gamble, which you shouldn't, these games are rigged so that the host always wins money. And so, for example, CPM Land is mean because they win 30 cents every time you play. And now, obviously, you can't lose 30 cents when you actually play, but if you played 100 times, then on average, you would lose 30 cents every time. So, the moral of this story and this problem is A, do your math, and B, do not gamble, because you will always lose in the end. Isabella, out.